You know, sometimes math can be a lot of work, annoying, tricky, challenging, and then there are some times where there are little tricks that can make things a lot easier. And we're going to go over one of those things coming up on the math review. Fractions. So this lesson is on dividing fractions with cross cancellation. Now, cross cancellation is a trick that makes dividing fractions a lot easier because instead of working with really large numbers when you're calculating your answer, it makes it so that you work with really small numbers, and those numbers are small because they've already been simplified, or in this case we call them canceled. Let's go over example number one, and we'll use each of these 4 steps. And then you can pause the video and try example 2 on your own based on how we complete 1 together. So let's get started. Here, this problem says 3 over 5 divided by 8 over 15. And step 1 says use KCF to create a multiplication problem. So we're going to write a KCF chart here to do so. So in KCF, the K stands for keep. So this 3 over 5 is going to stay exactly the way it is. The C stands for change. And what we're doing is we're changing this division into multiplication, just like it says in step 1. So here, we'll write our multiplication symbol. And the F here stands for flip. So what will happen here is 8 over 15 will get flipped. And that means instead of 8 over 15, we're going to have 15 over 8. Now step 2 is where it gets a little bit tricky. We've got to look diagonally each way for a common factor and use the factor to reduce. So that was really wordy. So let's slow it down and go over exactly what that means in this example. So when step 2 says to look diagonally, what it means is you're going to look at the numerator or the top on one fraction and look at the bottom or the denominator on the other fraction. So right now we're just going to look at the values 3 and 8. And we're going to ask ourselves, is there any factor or number that can divide both 3 and 8? Well, there is none. So let's look diagonally the other way now to see if that works. So now we're going to look at the values 5 and 15. Now let's think about that. Is there any factor or number that can divide both 5 and 15? Well, 5 can, and we're going to use that 5 to reduce each of these. So here we'll divide 5 by 5. And what's 5 divided by 5? Well, that's 1. So I'll cross this 5 off and replace it with a 1. And we'll do the same thing here to 15. 15 divided by 5 gives us 3. So we'll cancel out the 15 and put the 3 here instead. Next, what I like to do is make sure my work is neat, so I'm going to rewrite the fractions that I have here. So this fraction here, this 3 never got canceled out, so we'll leave it the same. So that'll be 3. But this 5 became a 1, so now I'll write that as 3 over 1. I'm going to keep my multiplication the same, and then I'm going to look at this fraction here. This was 15, but it became 3, so I'll write a 3 instead. Well, what about the 8? Did that get canceled out? No. So we're just going to rewrite 8 down here. So now we're dealing with these 2 fractions instead of our original fractions in the KCF table. And so now we can go to step number 3, which is just to multiply across. That's going to be 3 times 3, which equals 9, over 1 times 8, which equals 8. Now this is 9 over 8, which makes it an improper fraction, and we can't leave our answer like that. So what we're going to have to do is use division to change this improper fraction into a mixed number. And I'm going to rewrite that up top. So 9 is our numerator, so it's going to go inside the house. And my denominator 8 is going to go outside the house. Now how many times can 8 go into 9 without going over? Well, that's 1 time. And 1 times 8 is 8. When I subtract that, I'm going to get 1. And what that means is 8 can go into 9 one whole time, which means that the whole number in my mixed number is going to be 1. The remainder here is also 1, but since that's my remainder, that means that's going to be the top of my fraction in my mixed number. That'll be 1 here, and our divisor will stay as our denominator. So therefore, the quotient of 3 over 5 divided by 8 over 15 is equal to 1 1/8. Okay. That question was a little bit tricky at the end because you had to make sure that you knew how to change an improper fraction to a mixed number. But the cross canceling wasn't too bad, and it made it so that we had smaller numbers that we worked with. That was helpful. Why don't you pause the video and try the next example on your own? Good luck. All right, on to question 2. So we'll start with step 1, where we have to use a KCF chart to create a multiplication problem. So in KCF, the K stands for keep, which means we'll keep our first fraction, 8 over 27, exactly the way it is. The C stands for change, and what we're changing is our division into multiplication. So let's write our multiplication symbol right here. And finally, the F stands for flip. So I'm going to take this fraction 4 over 9 and make it so that the 9 is on top and the 4 is on the bottom. That gives us 9 over 4. And I want to zoom in to make sure that we make this crystal clear. So what we're going to do is we're going to look diagonally. We're going to look at the first fraction's numerator and the second fraction's denominator. So right now, all we're really focusing on is 8 and 4. And now what we need to do is ask ourselves, is there any number that can divide both 8 and 4? And if there is, what's the largest one? Well, the biggest number that can divide 8 and 4 is the number 4. So 8 divided by 4 is 2. So I'll cross off the 8 and I'll put a 2 right next to it instead. And what's 4 divided by 4? Well, 4 divided by 4 is 1. So I'll cross off the 4 and I'll put a 1 instead. Now remember, it's important to make sure you're dividing by the same number. I can't divide by 8 here and by 4 here, or by 4 here and by 2 here. I divided both 8 and 4 by the same value, which was 4. You're looking for the biggest number that can divide both numbers that you're focusing on. Now let's look the other way. So now we're going to focus on the numerator here and the denominator here. So I'll circle 9 and 27. So is there a number that can divide both 9 and 27? There sure is. And the biggest of those numbers is 9. So we're going to divide both 27 and 9 by 9. Well, 9 divided by 9 is 1. So I'll write that here. And here, 27 divided by 9 is 3. So I'll cross off 27 and I'll put a 3 instead. So now let's zoom back out. So now that we've cross-canceled both ways, we're dealing with really small numbers. But what I like to do to be neat is I like to take our new fraction and rewrite it so there's no confusion with all this work. So on this side, I've got 2 over 3. So I'll rewrite that here. I've still got my multiplication symbol. And on this side, I just have 1 over 1. And now I can go to step 3, which is to just multiply across. 2 times 1 equals 2. And 3 times 1 equals 3. So our quotient for 8 over 27 divided by 4 over 9 is 2/3. I love cross cancellation. It makes the math for dividing fractions so much easier because the numbers are smaller, so they're much easier to work with. What do you think? Let us know in the comments below. And also, if this video helped you, don't forget to like it. And make sure you subscribe to our channel so you catch all of our other math videos coming up. Thanks for watching.